question number 11. Figure shows a piece of metal in the shape of letter E cut from a uniform sheet. The center of gravity is mostly likely to be found at. We can consider vertical part and horizontal part. When considering this vertical part, center of gravity should be this point. And when considering horizontal three parts, center of gravity should be this point. But due to the weight of this part, center of gravity should be between these two points, and the large weight is horizontal part. Then center of gravity should be near to the horizontal part. Then we can get C should be the correct answer. Answer is 3 for the question number 11. Then 12. Identical laminate cut into laminas cut into the form of the letter E are provided vertically. Pivot vertically. At X, if G is the center of gravity of the lamina, which of the states shown in the figure are at stable equilibrium position? We know that if the pivot point is above the center of gravity, the object is at stable equilibrium. If the pivot point is on the center of gravity, then object is at neutral equilibrium. And if the pivot point is below the center of gravity, object is at an unstable equilibrium. Now we have to select the figures corresponding to stable equilibrium. A is correct. Center of gravity is below the pivot point. B is incorrect. It is in unstable equilibrium. C also correct. Pivot point is above the center of gravity. D also incorrect. It is a neutral equilibrium. Then A and C only. First one is the correct answer for question number 12. We have to remember that if the pivot point is above the center of gravity, it is in stable equilibrium. If the pivot point is below the center of gravity, it is in an unstable equilibrium. If the pivot point is on the center of gravity, it is in neutral equilibrium. Then 13. A frame is made by joining three uniform rods P, Q and R having identical geometrical dimensions as shown in the figure. Rods P and R are for same mass, but Q is twice as heavy as P or R. When the frame is suspended freely from the point X, its equilibrium position is most likely to be. They have given a frame like this. When considering vertical part, center of gravity should be midpoint, this point of the this point. Then when considering horizontal part, center of gravity should be this point. But when considering vertical part, this part, center of gravity should be this point. And they have given that weight of this part is twice the weight of horizontal part. Then center of gravity should be in this straight line and it should be near to this one, near to this vertical part. Then we have to consider given figure. Hanging point is like x. X is this point, midpoint of this horizontal part, and center of gravity is this one. Then vertical line should be this part, this one. Then we can draw vertical line corresponding to given answers. Yeah, we can join. We can consider vertical line of given answers. Then we can find the answer. We could obtain a vertical line like this. Vertical line like this. Then we can get. Second one is the correct answer for question number 30. Then question number 14. See, identical uniform books are placed on each other as shown in the figure. The center of gravity of set of books likely to be found at. There are 3 books. When considering center of gravity of each book, it should be center of gravity of this book should be this one. Center of gravity of second book is this one. Third book is this one. Then we can join center of gravity of 3 books. Then center of gravity of the system should be on this straight line. This is straight line. And for the equilibrium, center of gravity should be in the left hand side to this edge. Left hand side of this edge. Then we can get it should be like a point B. It should be point B. Then question number 14. Answer for the question number 14 is 2. Then 15. A toy in the form of a child figure holding a section of a ring, a thin ring, which carries 2 identical heavy metal balls, is made from a thin metal sheet as shown in the figure. If the toy can be balanced in stable equilibrium from the toe of the child, figure most probably the center of gravity of the system can be found close as the point. We know that for the stable equilibrium, center of gravity should be below the pivot point. Now we can consider this toe point is the pivot point. It should be, then center of gravity should be below the toe point, like this. We can consider the center of gravity of the system is moving in downward direction due to this heavy matter. Then answer should be T. 5 for the question number. Answer is 5 for the question number 15. Then 16. Water droplets drip at a constant rate from a tap as shown in the figure. The center of gravity of the system of drops in the air is most likely to be found. 1, 2, 3, 4, 5. There are 5. There are 5 water drops. And when considering symmetry, the weight of the system is spread as the large weight has the upper part. Then if it is symmetric, the center of the gravity should be a point like this, midpoint. But now the weight in upward side is a greater value, then center of gravity should be moved in upward direction, and therefore we can consider upward direction, and it should be a point near to this one, because of there is only one water drop more than in upward direction. There is only one. There are 3 water drops in upward direction and there are 2 water drops in downward direction. If there are 3 water drops in downward direction, we have to consider center of gravity should be midpoint. But when considering this system, there are 3 water drops in upward direction. Therefore, center of gravity should be at a point upward to midpoint, but it should be close to midpoint. Then answer should be R. 3 for the question number 16. Question number 17. 2 identical uniform bricks of length L are stocked without being toppled on a table as shown in the figure. Respective maximum possible values of L1, L1 and L2. Maximum possible values of L1 and L2. I will consider equilibrium of this above brick. For the equilibrium, its center of gravity should be in this point for the maximum value of L1. Then we can get L1 should be L over 2, and for the equilibrium of the system, the center of gravity of the system should be in this straight line for the maximum value of L1 and L2. If the center of gravity is in the right hand side, it will topple, and if the center of gravity is in left hand side, it is not the maximum possible value of L1 and L2. Now we can consider weight of the this brick should be like this, mg. We know that distance from this edge to this point is L over 2. Weight is acting at the midpoint. Therefore, when this length is L2, this part should be L over 2 minus L2. And this weight also mg. Now we can consider the torque of the system around this point O. Torque around point O. mg into L over 2 minus L2 should be equals to mg into L2. Counterclockwise torque equals to clockwise torque for the equilibrium of the system. Now we can cancel out mg term. Then we can get 2L2 equals L over 2, L2 equals L over 4. Then L1 should be L over 2, L2 should be L over 4. There is a pattern. If there are more than 2 bricks, L value should be L over 2, half of length of this brick, then L over 4, for the third one L over 6, L over 8, we can do that. Then question number 18. Figure shows a thin uniform L-shaped metal sheet. The center of gravity of the sheet is mostly likely to be found at point. We can consider the correct answer is 1 for the question number 17. 18. We can consider two parts of the given object. When considering vertical part or this part, center of gravity should be midpoint of the part. And when considering this part, center of gravity should be midpoint of this part. Then center of gravity of the system should be on this straight line. And when comparing length, we can consider that this vertical length is greater than horizontal length. Therefore, the corresponding point for the center of gravity should be like C. Then answer is 3 for the question number 18. Question number 19. A pencil is held vertically on its tip on frictionless table. Frictionless, it is important. As shown in the figure, when it is allowed to fall freely towards the plus x direction, the path of the center of gravity of the pencil is best represented by. We know that if the given plane is rough, the pen should be fallen like this. But if this point is not rough, it means frictionless, this should be moved like this. Therefore, for the first situation, rough situation, the movement should be like this. Center of gravity is moving in a circular path. But if this point is smooth, it is sliding and center of gravity is moving downward direction. Therefore, answer is 5 for the question number 19. Question number 20. A rod XY rests between two smooth boards P and Q. So PQ and QR kept inclined to the horizontal as shown in the figure. Angle PQR is 90 degrees and the surface of the boards are normal to the plane of the paper. The center of gravity of the rod is most likely to be found situated at the point. Again, we can consider two parts of the given object. Center of gravity of this part should be midpoint of this point, this part. And center of gravity of this point, this part should be midpoint of this part. Therefore, center of gravity should be on this straight line. And when considering length of given two parts, center of gravity should be near to this part. It is the it is longer than this part. Then we can get the center of gravity should be near to this part. Then answer should be, it is not in the same horizontal plane. This line is like this, is like this, and this joining line is like this. Due to this part, center of gravity is moving in upward direction and right hand direction. Therefore, center of gravity of the object should be a point like C. Then answer is 3 for the question number 20.